Hey there, folks. So this particular video is about a solving method called completing the square. Now, you might be familiar with already factoring methods, or you might be familiar with something called quadratic formula. Okay. Completing the square essentially is whenever a quadratic or another polynomial is not factorable, that is a useful method of solving. Okay. So one of the main things about this is the fact that it's not going to be factorable when you try to figure out two factors that will, if you multiply two factors together, will give you this particular quadratic. And so instead we use a method called complete the square, completing the square. And what's useful about this particularly is that there's another form called standard forms, which deals a lot in conic sections, for example, where this will also get you the vertex form for equations like circles, ellipses, parabolas, so on and so forth. And so the idea is going to be to change this into something called a binomial square term in order to solve it. So the first step is going to essentially going to be this. We want to make sure that whatever this constant value is going to get shifted, or in this case added, to the other side of the equal sign, because we want to isolate the two variables p squared and p here. And I apologize for the wires getting in the way. And when we do this, what we're going to do, or at least the way I prefer and kind of like to do, is I'm going to leave another blank where I took that 38 away from. And at the same time over here, I'm going to add in that same blank I added in over here. Because essentially what I do to one side, I have to do to the other side as well. Now, here's kind of the kicker to this. You want to make sure you understand that this is your A, your B, and essentially what becomes your C. And we're going to essentially take our A, our B, and create a new C value. Okay. And this is the one that's going to kind of get us what we need in order to solve this. So the way you do this is we take our B term, okay, and we're going to take our B term. I'm going to do it down here before you, below. And we're going to divide by 2. And then whatever number we get, we're going to take that and we're going to square it. Okay. And yes, this is the method for finding this new C term that I have here, the constant term. Okay. Well, if I do 14 divided by 2, which is 7, and then I square that number, that's going to give me a value of 49. Okay. So this is going to be 7 squared, which comes out to be 49. Okay. Well, since I added 49 on this side, then I want to go ahead and add 49 to this side as well. Again, what I do to one side, I want to make sure I do it to the other side. Okay. So then what I do is I want to take my trinomial, 3 terms, and I want to convert it into what's called a binomial square. So what it is, and if I factor this, what I get are 2 factors that are both x, I'm sorry, not x, p plus 7 and p plus 7. So now what happens is, and you're going to probably ask, is where did the 7 come from? Well, it's because right here, if I divide it 14 by 2, I got 7 squared. Now, the other way to look at this is if you're familiar with a method called FOIL, if I did p times p, that would be p squared. If I did 7 times 7, that would be 49. And then if I do 7p plus 7p, that is 14. So this trinomial, after you complete this particular, what we call perfect square, becomes 2 factors that are p plus 7 and p plus 7. And yes, this number essentially does come when I divide 14 by 2 to get 7. Okay. And then rewrite this as what's called a binomial square. Okay. Now what happens on this side is we go ahead and we add 38 plus 49. And that's going to give us, I can't do math right now, 87. And now we have this in what's basically essentially called a vertex type form equation. Now, don't want to get too much into it, but I could rewrite this by subtracting 87 to this side to get a vertex form for parabola. That's not where I want to go with this, okay? What I really want to go with this is the fact that the process being that you take your C value and you add or subtract it to the other side. Wherever that C value was, I'm going to create a new C value by completing the square. And again, I'm looking for a perfect square. And in order to do that, I take my middle term, which is the B term, or the B, divide by 2, which becomes 7, and then I square that number to get me 49. So now I have actually completed the square. What I do to one side, I have to make sure I add it to the other side as well. So then this trinomial, if I were to factor it out, would become two factors that are both p plus 7 and p plus 7. And again, because if I actually FOILed this, I'm going to write the word FOIL out here, then that would give me back to what I started with. And then I take my two factors and I write them as what's called a binomial squared term. And the reason why it's binomial, because it's two terms, which makes it a binomial, hence, and then squared. And that's how you actually complete the square. If I was going to solve from this step, which is pretty common thing to do, I would actually square root both sides first. That's how you get rid of a square. And I normally don't deal with decimals on these, so I'm not going to mess with this. I'm going to leave it as the square root of 87. But anytime you square root, you always have to have plus and minus. Okay. And then I'm going to subtract 7 to both sides. So the value of p, if I was solving this, would be -7 plus or minus the square root of 87. Okay. So I'm going to give you another one here. I lost my papers now all of a sudden. Let me pause this. Anyway, try it, see what you can do. I'm going to pause it here again. Try it out. And then I'll come back with what it looks like here in a second. Okay. All right, this is where you should be at this point. So again, I add 59 to both sides in this case. I'm going to leave this blank to create a new C term. And to create that new C term, I'm going to take my B term and my middle term, divide by 2, and square it. So that's 3 squared, which is 9. I'm going to add 9. I'm going to add 9. Okay. This term is going to become v plus 3 if I was to actually factor it out. Now, I know maybe one of the questions might be, how do you know this is plus or minus, something like that? Well, it's usually, if this was a 14 here, or positive 14, I got a positive 7, this would be positive 7. Here, I had a positive 6, so that makes this a positive 3. Okay. Now, the other question that might pop up is, are here always plus a number? And the answer actually is yes. And the reason being is because you square a number. When you square a number, you're going to create a positive value. So then this becomes a v squared term. And again, if I solve it, then what happens is I would square root both sides. Okay. Now, I'm not going to quite leave this as the square root of 68. This is going to go back to another skill or concept about how you simplify radicals, which I'm going to show you real fast again. But if I take 68, that would be the same thing as saying, let me see, I forgot my numbers were all of a sudden. Yeah, 4 times 17. Okay, and then 4 would be 2 times 2. 17 is just 17. Can't do anything about it. So the square root of 68 would become 2 to the square root of 17. And because I square root it, it'd be plus or minus. And then I'll subtract 3 from both sides so that my solutions would be negative 3 plus or minus 2 to the square root of 17. Okay. So now, let me find the rest of my papers here. So those are all nice and neat. Okay. So now if I have another one, I'm going to show you another one. Yeah, this looks pretty good. Okay. Now the difference between this and what I've done beforehand is this number here. The fact is you have a number in front, a leading coefficient of 2. So what I did a minute ago on these first two was if your leading coefficient here is 1, okay, this is what happens if your leading coefficient is not 1, whether it's 2, 3, whatever it might be. So the nice thing is I'm going to kind of do the same process, and you know what I realized? This is going to give me a negative, it's going to be an I answer, which is probably more than I need to, but it's not going to hurt anything. So I'm going to go ahead and I'm just going to go ahead and do this and just at least give you the idea how to get to this point, okay? So again, I'm going to subtract 67 first from both sides. And again, I'm going to make this 2x squared minus 5x, okay, equals to negative 67. Now notice I didn't make a new spot here yet, and the reason why I didn't make a new spot yet was because of this 2. So what I'm going to do before I create a new spot is I'm going to divide everything here by 2. I'm not going to do the negative 67, just so that you know, okay? That comes in a solving phase. So I'm only going to complete the square to show you what this is going to do here, okay? Especially since there's going to be a fraction involved. So I'm going to rewrite this minus 5 over 2x. I'm going to show you how to deal with fractions here because fractions do, play a part of this. And I'm going to go ahead and add in my missing part here. And then I'll take care of this side here in a second, okay? Now here's what happens. I'm going to take my middle term again. And I'm going to divide by 2. Now it is easier that instead of dividing by 2 to multiply by 1/2 squared. So I will do this with fractions. That way it makes things a little bit simpler to work with fractions. Okay, you're still dividing by 2, but instead of me actually dividing, I'm going to multiply by 1/2, which is the same process, same idea. Okay, and that's going to give me 5 over 4 squared. Okay, and then 5 over 4 squared is going to become 25 over 16. Okay. And if you're not sure, use a calculator. If you can't square 5 and you can't square 4, use a calculator. We have it. On this side, I'm going to do the same thing where I'm going to add, like I normally would, that 25 over 16. But here's the catch. Because of that 2 that's sitting right out here, I've got to make this even, kind of like balancing equations in a sense. And if I was to actually do this, I would actually multiply 2 times this term. So therefore, over here, I need to make sure to multiply this by 2. Okay. And again, I'm just going to complete the square with this. I'm not going to fully solve this because I do know the solution. This is going to be imaginary, and that's a little bit further, work and further detail that I'm not going to get into in this particular video. Okay. So once I have all this, okay, I'm going to do the same thing I did a minute ago, but this time I do have a leading 2 in front. And remember how we got this 5 over 4? And if you remember how this is a negative here, then this is going to become x minus 5 over 4, x minus 5 over 4, kind of like that. And then I'm going to write this as the binomial squared term, kind of like this. And then I'm going to get all this equal to, and I'm just going to just plug it in the calculator for you so that you at least can see it. Negative 67 plus 25 over 16 times 2. And that gives me a negative 511 over 8. And again, fractions are just a part of this. Not going to do much about it. And you have at least completed the square. Okay. I'm not going to finish solving this because if you can get to this step, you will actually be okay. Solving this, like I said earlier, it's going to be it's a whole nother video. Okay, and I'm not going to put it on this particular piece. So I'll give you another one here in a second. And then you can try it one more time, but that'll pretty much finishes out. I'm pausing here. All right, here's another one. So first thing, and I didn't mention this beforehand because I think they were all set up like this, but I kind of realized I need to probably mention this. When we do this, you want to make sure that your x's are on the same side of the equation. So I'm going to go ahead and just subtract 8x to this side in order to set it up the way I want it to. And I don't actually have to move the negative 4 since I need it on the right hand of the side of the equation sign anyway. But now what I'm going to do is I'm going to go ahead and do the same thing. Since there's a 3 leading coefficient in front, the first thing again I'm going to do is I'm going to go ahead and divide the first 2 by 3. And again, yeah, you deal with fractions, but you might as well live with it. No, don't do decimals. Although you can't, they are usable, but I'm going to tell you, you're not going to want to do decimals. Okay. So now I'm going to take my middle term, and again, because it is a fraction, instead of dividing by 2, I just want to multiply by 1/2 instead, and then square that term. Okay. And that would become 8 over 6 squared. Now, the question might rise, can you reduce this to 4 over 3? I'm going to tell you, don't really reduce anything until the very end. And again, that's just to make sure everything stays nice and neat. That's my personal preference more than anything else. Okay. But anyway, that would be 64 over 36. And again, if you're not sure how to do 8 squared and 6 squared, just, use a calculator. And then to balance it, I'm going to put it on this side. But again, remember that little 3 up here in the front that we have to divide out first? I'm going to multiply this side by 3 too. Okay, and that's just to balance everything out. So I'm going to take this into my 2 factors. So x minus 8 over 6, x minus 8 over 6, okay, which becomes your binomial factor of x minus 8 over 6 squared, okay. And then on this side, is all of this, which, let me see. Plus 64 over 36 times 3 is 4 over 3. Okay. And then from this point on, you would solve it. You would divide by 3 first. Now, when I divide by 3, I'm going to multiply this side by 1/3. It's dividing by 3 and multiplying by 1/3 is the same process. Okay. And that would become 4/9. Then I'm going to square root. And anytime you square root fractions, you have to square root each individual piece again. I don't know why I wrote that again. So the square root of 4 is 2. Square root of 9 is 3. And again, because we square root it, it's plus or minus. And at this point, because I see this 3 sitting here, I'm going to go ahead and reduce this down to 4/3. Because I know I'm about to use a denominator of 3, which makes it simpler to add and subtract. So that's the reason why I say wait to the end, because once you see what your answer is here, if this would have been a 6 denominator, I would have wanted to use 8/6, but since I see a 3 denominator, I'm going to change this to a 4/3. That way, I can add 4/3 on this side. One answer is 2, and the other answer is negative 2/3. That's what it looks like. Or is it positive? It's 4 minus 2. It's positive 2/3. Sorry. The other one is positive 2/3. Okay. But that's how you solve, that's how you complete the square. Yes, it looks like a lot. And I'll be honest with you, when you see this, there are a lot of steps you probably can skip as you go through this. Like, for example, I don't necessarily need to write the two factors out. If I understand going from here to here is binomial factor. There are a lot of steps like here that, you could probably do this in your head or with a calculator to get this term here. So there are steps you can skip. This is just kind of a full-fledged, what a problem would look like if you complete the square, or if you have to solve it with complete the square. All right. I will. Yes, I am being invaded, apparently. We'll talk to you all later. Peace.